So hopefully you watched the first two videos. The first one was just a funny one about Price is Right for a game called Plinko. And basically, if that person kept putting Plinko chips in and they left them where they were, over time it would form a normal distribution. And you saw that with the second video, which was from the Boston Museum of Science. I've actually been there and seen that little simulation, and you saw as the balls fell down, it wasn't perfect, but as more and more of those little balls fell into the machine, it did form somewhat of a normal distribution. So that brings us to these pictures that you see here. Basically, if we were in class, these are pictures from previous years, each of you would get a little bag. So I'm just going to draw this out so we get the idea. And inside this bag, there were little chips, so little pieces of paper, and they were bigger than this, but maybe the size of a dime. And let's say some of them were red and some of them were yellow like this. So there was a bunch of them, much more than I drew. And in this bag, 40% of each person's bag was red. Okay, so that's the actual amount that's in there, and we're going to call this the population of chips. So this chart with Post-its came from each student taking out 20 chips from their bag and calculating the proportion of red. So we call this a sample proportion. So I'm just going to pick this person. This represents a student who picked out 20. So if they got 0.30 for their proportion, they had 6 out of 20 were red. Okay. Which equals 0.3. So they did that. They brought up a Post-it and they put their Post-it right here on the graph. So all of these represent student samples, and just like the Plinko game or the little simulation at the Boston Museum of Science, as we put these in, these start to form somewhat of a normal curve. And it's not perfect because if I counted these, there's maybe about 40 of them up here. Okay. I'm going to show you a couple other student samples from other classes. So here's another one. So this is another class. If we went back and forth, we'll notice this one we had a little bit taller here. We have less on the sides, more towards the middle. I have one kind of tall section here. Here's another one. This was a smaller class, so we didn't get as many Post-its up there, but you see it's starting to form this shape. Now here we have an outlier at 0.80. So that meant 16 out of 20 for that person were red. So that can happen, but those outliers, since the actual bag only has 40% red, don't happen very often. Here's another one. As I said, each one looks a little different. And even if you were going to pause the video on that Boston Science Museum simulation, you would see that in the beginning, it didn't really look like a normal curve. It started to, and you started to get that idea, but as more and more of this information is added, it starts to resemble the normal curve. And with that, it was just little balls falling down. Same thing with Plinko with Price is Right. Here, it's actual samples from a population. So samples from a population are another thing that forms a normal curve. If we keep taking these samples, we see it's centered around what the actual proportion is, okay, and there's less and less as we go out to the sides. So using this fact, we can use what we learned about the normal distribution to make decisions from these. Now, this is never really used this way because if we were in class, we would say it would take about 15 to 20 minutes to create this graph. We don't even have that many samples. Basically, you can easily program this information into computers and use things with random numbers to generate simulations like this, which is what we're going to see in the lesson.